All right, so 3 topics that we're going to talk about today is tree diagram, creating an organized list, and then also that shortcut method we talked about, the fundamental counting principle. So if you were asked to find the different combinations, you must create a tree diagram, which is one method. Tree diagrams may be created vertically or horizontally. The number of possible outcomes in a probability experiment is called the sample space. So the number of possible outcomes is your sample space. So let's look at this first example. We had that abnormal slide. You can order vanilla, chocolate, or strawberry ice cream in a cup, sugar cone, or waffle cone. We're going to list all different combinations you could order. So usually creating a tree diagram is helpful for creating then your list. Okay, and that's what we're going to do. So we have 3 choices: vanilla, chocolate, strawberry. So we have 3 choices here. And how many choices do we have? Yeah, so we have cup, sugar cone, waffle cone, right? So we have another 3 options, which is why there are 3 branches, right? Tree diagram. All right, so you can have vanilla in a cup, vanilla in a sugar cone, waffle cone. Okay, same thing for chocolate in a cup, sugar cone, waffle cone. Please stop. Thank you. Are you copying this down? Yeah. All right, thank you. Strawberry in a cup, sugar cone, waffle cone. So can you kind of see how then it's easier to create your organized list? Usually organized list, you're going to see acronyms, I guess you could say. So you'll see like this: vanilla cone, vanilla sugar cone, vanilla waffle cone. You'll usually see it abbreviated or kind of like the acronym, the first letter. And then we have a chocolate in a cup, chocolate in a sugar cone, chocolate in a waffle cone. And then we also have strawberry ice cream in a cup, sugar cone, and a waffle cone. So there is your organized list. All right, and that's what they asked, right? They want you to create a list, just like the warm-up. All right, so also, we made a tree diagram. Can you draw it, a different tree diagram to represent the same sample space? How can we do that? Any ideas? How many options are there? So that means we're not starting out with vanilla, chocolate, and strawberry. We're starting out with the containers. Okay, and there are how many containers? 3. There's cup, and so wherever there's space, we have a cup, sugar cone, and a waffle cone. Right? So we had 3 options. How many options of ice cream? 3. So you'll need 3 branches. Right? And then we're going to list our 3. So in a cup we can have vanilla, chocolate, strawberry. In a sugar cone we can have vanilla, chocolate, strawberry. In a waffle cone we can have vanilla, chocolate, strawberry. So there's more than one way to draw a tree diagram. Okay, and you'll kind of see that as well. Okay, we're going to go ahead and apply the fundamental counting principle. How would we do that? From the video. Or that's kind of what Addie did for the warm-up. She had the total amount instead of the list. How do we do that?
You do 3 times 3.
Because there are 3 options for ice cream, right? And there are 3 options for containers. 3 times 3 is 9. So notice you have 9 outcomes here. And for a tree diagram, you count the end of the tree, end of the branches. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we did a second tree diagram. You have 1, 2, 3, 4, 5, 6, 7, 8, 9 possible outcomes. So that's your sample space. Questions? Okay. For example 2, you're going to draw, you're doing the same thing as a just list. So they want a tree diagram, they want a list, and then they want a second tree diagram. All right, and then example number 3, they want you to list all the possible outcomes, and so you can go any route that way. So I'll give you a few minutes, and we'll see how you do. So number 2, you roll a die, and you flip a coin, list all the different outcomes. So it looks like they started with a tree diagram first, and they kind of got it started for you. They started with the die, right? And then this is going to represent the coin, right? What are the outcomes on a coin? Heads or tails? Heads, tails. That would be there. Yeah. Are we good with that? So then you can create your list, right? So you can have 1 heads, 1 tails, and then so forth. And then did you create a different tree diagram? All right, so once you just, like, we're going to start off with the coin, right? Let's see, let's do it this way. So we have heads, and how many branches? 6. And then you numbered it 1, 2, 3, 4, 5, 6. That's for heads. And then you also have tails, and you have better, and then numbered it for your die. 6. Is that your second one? How'd I do? Great, that second one. Yay, good. All right, and then you are flipping 3 coins, list all of the possible outcomes. I got 8. Yeah, that's good. Okay, so you can have all heads, right? Heads, and then there's 1 tails. Heads, tails, heads, and then heads, tails, tails. That's the first, right? And then you're going to have, I might get distracted, tails, right? Tails, heads, tails, heads, tails, right? Tails, heads. Did you get that? So there are how many outcomes? 8. How could you do the shortcut method? How many is each of them? And then what operation do you do? 2 times 2 is 4. 4 times 2 is 8 outcomes, and you'll see that there as well. Okay, so let's flip it over to the back. Our nice little shortcut method, the fundamental counting principle, is used to find the number of possible combinations or outcomes. So you're kind of bypassing the list and the tree diagram. To determine the total number of outcomes possible, you're just going to multiply the total number of each situation or each event. Okay, just like we took each coin, 2 possible outcomes, 2 possible outcomes, times 2 possible outcomes. And so they did example number 4 for you. So we had jackets come in red, blue, or green. Okay, so the jacket color, there are 3, right? And then the sizes, there are small, medium, large. So 3 times 3 is 9 possible outcomes. Are we good with that? All right, so go ahead and complete the page using the fundamental accounting principle. Okay? I'll give you a few minutes and then we'll check and we'll create a poster.
All right, at Fuzzy's Pizza, you can order your pizza with thick, thin, or hand-tossed crust. They have small, medium, large sizes to choose from, and cheese, pepperoni, sausage, hamburger, and Canadian bacon toppings. How many different combinations of pizza could you order? So we have 3 crusts, 3 sizes, and 5 toppings. So we have, good, 45 possible combinations. Give them one big clap. 1, 2, 3. Questions? All right, number 6. Nikhil, pick a number 1 through 15. 12, come on down. Number 6, a test consists of 5 true or false questions. How many possible outcomes are there? Each question. You have to do each question separately. Each question is a separate event. So question number 1 has how many possible answers? Question number 1, there's 5 questions, right? Okay, so write 2. Question number 2 has how many possible answers? Good. Keep going. Do that for all 5. There you go. Did y'all do that? A lot of people want to do 5 times 2. It's just like the coin, y'all. If you have 5 coins, like on the front page. Good. 32 possible outcomes. One big clap. 1, 2, 3. All right. Example number 7. Do we have a volunteer? Addie's already shared.
13.
All right. 13. Come on down. That's Addie. All right. Go for it. 4 coins are tossed. How many possible outcomes are there? So do each event. Each coin is an event. Good. 2 outcomes. 16. Give her one big clap. 1, 2, 3. All right. Last one. Example number 8. Do we have a volunteer? Addie, pick a number. 14. Selma. Sonic offers 4 different size drinks, small, medium, large, and Route 44. They also offer 9 different flavors of fountain drinks. How many possible outcomes of drinks and sizes does Sonic offer? We know they offer a lot more flavors. Good. We have 4 sizes, 9 flavors, 36 possible drinks. Give her one big clap. 1, 2, 3. Questions? All right, so the last page you see in your packet is homework. Okay, so let's go ahead and put that out to the side, and we're going to create a poster.